Hello, welcome. This is question 4 for AQA's AS Physics, Unit 1, June 2010. Okay, so this question 4 is a very small question. There's only two parts to the calculation, and then the first little part is just simply a knowledge test for 1 mark. Okay, so we're told that electrons exhibit wave properties, which is obviously something we should know. What Part A says, what phenomenon can be used to demonstrate the wave properties of electrons? Now, don't be put off by the word phenomenon. It just means, what bit of knowledge do you know? And obviously, phenomenon sounds a little bit more intellectually more accomplished. So, AQA like to make themselves seem smart. Anyway, so the answer you would put, they accept two variations, either electron diffraction or electron interference. Okay, and that obviously comes from the double slit interference. Now, I originally put double slit interference, but that's the experiment. It's not asking what was the experiment that shows that electrons can have wave properties. What actually is it about that experiment that shows that electrons have wave properties? And obviously waves interfering constructively, destructively, so you can have electron diffraction or interference, okay? So it's up to you. I'm just going to put electron interference because it makes more sense to me. Electron interference. Okay? Then these next two parts of question 4 are just simply using the Broglie wavelength. I mean, I can't even say it, so whatever it is. Okay, so part B says, calculate the de Broglie wavelength of electrons travelling at a speed of 4.5 times 10 to the 5 meters per second. Well, the first thing I would do is write down all the information you know and they're given. So we're told that the speed that they're travelling, which you label as V, is 4.5 times 10 to the 5 meters per second. We also know, obviously, because it's an electron, we know the mass of the electron. And the mass of the electron is 9.11 times 10 to the minus 31. And it's obviously in kilograms. Okay? So that's all we know from this question so far. You should know that the de Broglie wavelength, lambda, is equal to h over mv, or the Planck's constant over the momentum of the electron. So therefore we also need to state what the Planck's constant is. Now, not necessarily you don't, but it just helps to show you all the things, so we can simply sub them in. Okay, so you know the Planck's constant, 6.63 times 10 to the minus 34 joules per second. Okay, so that's Planck's constant. And then it's just about subbing it in to this equation. Okay, so your wavelength is equal to 6.63 times 10 to the minus 34. Okay, over mass times velocity, so it's over 9.11 times 10 to the minus 31, okay, kilograms, times 4.5 times 10 to the 5 meters per second, okay, and then just whack all that into your calculator, and the answer I got was 1.6 times 10 to the minus 9 meters. Remember, that's the wavelength, so you do need the units with it, okay. Oh, it's given you units, sorry. Okay, so 4C says the muon has a mass equal to 207 times the mass of the electron. Now, the first thing I would do at that point, well, it wouldn't be telling you that for no reason, okay? So you just work out the mass of the muon. Now, you can either put it in the exact figure or just show your calculation you would do. Okay, so we know the mass of the muon, which is just a heavy electron. Just like the tau, we've got the muon, the tau, and the electron. They're all of the same element, pretty much, but just one is, they get progressively heavier. So the electrons are lighter, then it's the muon, then it's the tau. Okay, just heavy versions of the electron. Okay, so anyway, the mass of the muon is 207 times the mass of the electron, and then we know the mass of the electron is this 9.11 times 10 to the minus 31 kilograms. Okay, so that's the mass of the muon. Calculate the speed of the muons, so we don't know their speed, so you put V is equal to, I just put like a little question mark to make myself seem like some kind of intelligent being. Okay, calculate the speed of the muons with the same de Broglie wavelength as the electrons in part B. Okay, so basically our lambda is this, what we answered for 1B, which is 1.6 times 10 to the minus 9 meters. Now, a couple of things I just want to mention. This value, obviously, you sub it in your calculator. Hopefully, obviously, you might have worked out the mass of the muon and put it as an exact figure. But what I would do is just simply, if you got rid of that calculation for 1B, do the calculation again, and then when you get your answer, leave that as your saved answer in your calculator. So, you know, that little answer thing, as I was going about. Maybe it's just me being lazy. Maybe it is. Anyway, so we're asked to find the speed of the muons with the same de Broglie wavelength. Okay, so obviously we know that Planck's constant again is 6.63 times 10 to the minus 34. Now, as I said, it's totally up to you whether you write out all the bits of information at the start of the question. But as I said, you know, I've got life to waste. Anyway, so this time we still write down the equation. Now it's up to you again whether you rearrange the equation at this point or sub in the numbers then rearrange. Okay, I always like to sub in the numbers then rearrange just to show where I'm going through. But as I said, it's totally up to you if you rearrange that, and it is quite an easy equation to rearrange. But anyway, so the wavelength is 1.6 times 10 to the minus 9 meters, and that is equal to Planck's constant, which is 6.63 times 10 to the minus 34, okay, and that's over the mass, which is 207 times the 9.11 times 10 to the minus 31, and we times that by the speed, v. So what I'm going to do is times both sides by v, in other words, move the v over to the left hand side and divide both sides by 1.6 times 10 to the minus 19. So therefore the velocity is equal to 6.63 times 10 to the minus 34 over 207 times 9.11 times 10 to the minus 31. Okay, times that by the, so that's times 1.6 times 10 to the minus 9. Okay, now you might have worked out what 207 times 9.11 times 10 to the minus 31 is, but I can't be bothered, so it's just easier for me to do that. Anyway, so shove all that into your calculator. You should get an answer about 2,176.3 meters per second. Let me see what they've rounded it to in the exam. Yeah, they've rounded it up to 2,200, but they do accept it rounded to 2,170. Yeah, so it's up to you how you round it. If you just put the velocity is 2,176, okay, that would be absolutely fine. Now, in the exam, as I said, they would have carried their error in terms of, you know, if you'd have got a wrong wavelength somehow for part B, but then got part C correct, then obviously if you followed the same basic method in terms of subbing your value for part B into the equation and obviously timesing the mass of the electron by 207, you still would have got all the marks for part C, just maybe lost a mark for part B. But that's obvious, that's kind of carry on crap. So, you know, if you do want me to have a look at, or go through whatever, please let me know. But if there's anything that you don't get how I did, hopefully, hopefully it does make sense. Please do let me know in the comments, and we'll see you in the next video, which I think is question 5. Exciting times. There's a big question, question 5, so enjoy.